We're going to talk about database indexes, table indexes more specifically. What's an index? So the easiest way to explain an index is to use an index. So normally in the classroom, what I have somebody do is open the book, tell them to look something up. So maybe you want to look up how to use a for loop, right? So you flip to the back of the book and there's an index there, right? And you go down through and you look for the alphabetical order. You look for the word for to find for loops. And then it tells you what page to go to, and you go to that page. That's way faster than going through each page individually in your book until you find a page about for loops, right? So we use the index to speed up the time it takes us to find our data. That's what an index on a database too. An index is technically a special table that the database can use to speed up the time it takes for somebody to do a query. Okay? And they work just like the index of a book. Okay. However, they also need to be updated every time the database object is updated. So think about your book. If I decide to add a chapter or a page or a paragraph somewhere in the book, it may change the location forward or backwards, or if I take some things out, it may change the location of that information that we're looking for about for loops, right? So every time we update the database, we have to update the index. Because of that, they can slow down updates and inserts, because every time we insert something, so if we have to insert 500 people into the person table, that could be a problem. That might make, because it might run slow, right? Every time we insert a person, it's got to go update the index. Okay. Then we insert the next person, it's got to update the index too. Where if we didn't have the index, it could just insert the people without updating the indexes and it would run faster. So there is a drawback. So you don't want to use indexes everywhere. At first it sounds like, hey, that's the solution. Let's just index everything. It does slow things down, so you don't want to do a bunch of indexes on a table that's constantly being updated. So let's talk about different kinds of indexes. Microsoft SQL Server has two kinds of indexes, and the first kind is called a clustered index. Okay, so a clustered index. Each table can have only one clustered index, just one. Okay, and clustered indexes define how the data in the table is going to be stored. Since we can't store the data in more than one way at a time, we can't have more than one clustered index. And this next statement kind of clarifies that a little bit. Clustered indexes are automatically generated in SQL Server when the primary key is created. So every time we make a primary key, there's automatically going to be an index based on that key. And basically the table is going to be kept in the order by that key. So it makes everything fast to find based on that key. So we can't sort other columns in order to put a key on them because it's already sorted by this key over here. And if we sort by another column, then it's going to mess up the first key. That's why there can only be one. Okay. So an index is technically stored in a binary tree. In a clustered index, the value of the primary key is used and the table is kept sorted by that value. All right, so let's go look at our person.person table. And here it is. We can look, we see our columns, we can see our keys that we might have. We have a primary key on business entity ID. It's also a foreign key. But down here we have our indexes, and we can see there's a bunch of indexes built on this table already, but only one of them is clustered. And you can see that right here it says clustered, and that's the primary key for the business, for the person based on the business entity ID. So this table is kept indexed based on that primary key, and it's kept in that order all the time. Okay. So one clustered index, by default, it will be on the primary key of the table when it's created. So the other kinds of keys are non-clustered. Okay, we're not even going to talk about these ones down here, these XML keys. We'll look at this one. Here's a unique key based on the person row GUI ID. That's another unique ID. And you can see that column is a unique column. But this one has to be non-clustered. We can't sort by this column as well. We're already sorting by the primary key, and we keep things in order by that. However, we can generate an index table based on that column. If people are searching on it often, we might do that. And I will show you how to do one in a minute. The theory of how this works is way more complicated than the actual process of creating the index. So let's look a little bit more about non-clustered keys. So a non-clustered index, not non-clustered key. We can create as many non-clustered indexes on a table as we need. Non-clustering indexes contain key values and pointers to the data row. Think about that index in your book, right? The key value would be the word, the term you're looking up, and the pointer to the data row is like the page number that it comes on, right? Therefore, the pointer is referred to as the row locator in this point. All right. So how do we actually use one of these? They're really not that complicated. It is one of two possible statements, really. We can do this. We say create index, and we give it a name on, and then we tell the table we want to create the index on, and we give it a column name. What column in that table do we want to index? This is the one that's done automatically on the primary key for us most of the time. If we want to create a non-clustered index, it's just create non-clustered index. And we give it a name and what table, and inside the parentheses, which columns do we want to index by. So for instance, on our person.person table, if we wanted to do this, let's just copy this and we'll fill in the data on it. Okay. Index, let's call this index our names index. I just gave it a name. Sometimes we can use the words IX in front of it to know that this is an index if we see it. So we're going to create a non-clustered index called names index on the person.person table. And here we list, separated by commas, the column names. So if somebody is searching our table constantly for first and last name, we could index those. We could do last name, do we need to use, we can just use the column name. It's already telling us. I better go look at my column names and make sure I'm doing this right. Last name. This would create an index on the last name only if we were only searching on last names. But if we're searching on last names and first names, we might want to do a combo. Okay. So let's run this statement. I'm going to highlight it. Command completed successfully. If we come back over here to our indexes, and we will refresh, and there's our names index. It's a non-clustered key, or non-clustered index. The index is based on first and last names. Okay, and that will speed up our searches anytime somebody searches using a first and last name. Okay. If we're just searching on last names, maybe we want to do it without the first name. But if we're doing both a lot, we'll put the index on. Now, something you should know about indexes is after you create one, you kind of monitor your database. Did it actually speed it up? If it didn't, maybe I need to try something different. But really, that's all there is to indexes. Okay. You create it, tell it you want to create it on, and the system does the rest. It creates the index and speeds everything up. How do we do this in SQL Server Management Studio using the GUI? Okay. So what do we need to do is expand the table node in Object Explorer where we want to create the index. Right-click the indexes folder. So if we're on person indexes folder, we can right-click it. We can say new index. And we pick the kind we want. We're not talking about any of these other ones, so we're just going to do a non-clustered index. Notice it won't let us do a clustered index because one already exists on the primary key. So let's create a new non-clustered index. Select the columns and give it a name. What columns do we want? Let's do, this one's going to be on the last name. And we can give it a name. It's going to give us that by default, but we can give it a better name. What did we call the other one? We called it names index. We'll call this last name index. Say OK. And we just created a new index called last name index. And there it is. So searches based on the last name will probably be a bit faster now. Remember, both those indexes are going to slow down inserting or updating data on this table, because every time we insert or update a piece, it has to stop to update the index as well. All right, that's going to be it for this video. Make sure you know the difference between a clustered and non-clustered index. Make sure you know the simple statement to create one and when and how you use them.